To add monomials, we must have a common denominator. So we're looking at these two and finding the common denominator. To find that, I think the best way is always check the largest number, and with the letters, it's always the highest exponent. So right now, my common denominator looks like it would be 8, because 2 goes into 8, x cubed, and then y squared. And the reason for the x cubed is because it's the highest exponent, and y squared is the highest exponent because there's none over here. Once we know the common denominator, we're going to multiply the numerator by what's missing from that common denominator. So we have a 4 that's missing. We have no x cubes are the same, and we have a y squared. So by doing that, I get 12y cubed for my first. And then my second one would be 5z. What's missing from that denominator? Well, the 8's there, but we're missing 2 x's, and the y squared's there. So if I multiply that, I get 5z x squared. So now, once I have the common denominator, I can add those two, and since they're not like terms, my answer is just simply writing an add sign between both problems with the common denominator. And there's the answer for that. Same with this problem, we have to find a common denominator. The best way to do it is just to multiply the 16 times the 5, which is 80. So our common denominator is going to be an 80 with the number. Once again, the letters are simply the highest exponent. In this case, A3 and A2. So now that we know the common denominator, I'm going to multiply this numerator by whatever is missing. And in this case, it's missing a 5 from the denominator, because 5 times 16 is 80, and it's missing a cubed. So when I multiply that, I get 15a to the 5th power, and that's going to be over 80a cubed b squared. And then I multiply the other one, which is 8x, by what's missing from the denominator. So we have a 16 that's missing. The a cube is there, but we're missing 1b. My fault. 1b. It's not 2b's. The reason why it's 1b is because it already has 1b. When I multiply those, I get 128bx, and that's over 80a cubed b squared. And if I'm subtracting, I just subtract like terms. Well, the numerators aren't alike. So my answer ends up being 15a to the 5th power minus 128bx over the common denominator. And so there's my answer. Alright, to do subtraction is the same as addition. We have to factor our denominators so we know what we have for our common denominator. So I'm going to factor both of those, and this becomes x minus 3, x plus 2. That's this part. And then this one, our greatest common factor is 5x plus 2. So my common denominator is everything. My common denominator is going to be x minus 3, x plus 2, and the 5. So I'm going to take my numerator, x minus 1, and what's missing from that denominator? I have an x minus 3 and x plus 2, so I'm missing a 5. So I'm going to multiply that by 5. Then I take the other numerator, 4, and what's missing I'm going to multiply by. Well, it has a 5 and an x plus 2, so it's only missing an x minus 3. So from that point, I can then multiply that, and I get 5x minus 5. And in this one, I get 4x minus 12. And if I'm subtracting, I can subtract the like terms, which gives me 1x. And if I subtract this, this becomes a plus 7. And that's over my common denominator, which is x minus 3, x plus 2. And so my answer after subtraction is that.